So let's say the net external forces is equal to 0. Okay? Let's begin from there. Now this net force, let's fix it and put net external. It means the system is isolated. Do you understand? There are not external forces acting. Okay? Now you remember that impulse is equal to F net multiplied by time. Is that correct? Okay. Now, if the net external forces is 0, the impulse of the external forces is also equal to 0. Is that clear there? So this impulse here, my lovely, this impulse, I'm going to write the external forces, is going to be equal to 0. Alright? But you also remember the impulse momentum theorem. Okay? What does the impulse momentum theorem say? Impulse is equal to the change in momentum. Okay? So let's write it here. Impulse is equal to the change in momentum. That is the impulse momentum theorem we learned last time. Okay? So if the impulse is 0, I stop there, it means that the change in momentum is also 0. So if change in momentum is 0, if momentum does not change, therefore it is constant. If momentum doesn't change, it means it's constant. Simple. If it's constant, means that the total momentum initial should be equal to the total momentum final. It did not change. All right, but let's do this. Change in momentum is final momentum. Total, speaking about total. Remember, we're speaking about interactions here. So total final momentum minus initial total momentum is equal to 0. Is that correct? Are you with me? If we rearrange that one, we get that the initial total momentum is equal to the final total momentum. Yeah? We're speaking about total. Alright? This is the law of conservation of momentum. Important, this one is for an isolated system. Isolated system. So, furthermore, here we can now break this one even more. You can start from there, but we can break it more. What is total momentum initial? It's the addition of the momentum initial of all the objects. Let's say, for instance, we're working with 2 objects. Could be 3. Alright? The initial momentum of object 1 plus the initial momentum of object 2 is equal to, let's make 2 objects for this interaction, this collision. Alright? Is the final momentum of the first object plus the final momentum of the second object. So far, so good. Okay. This is a beautiful one. P initial 1. When I say 1, I mean object 1. Object 1 could be car. And object 2 could be the wall the car bumps to. We can break this one even more because momentum is equal to mass multiplied by velocity. So let's do that one. Let's do that one, get further on and say initial momentum of the first object will be mass of the first object, this is a 1, sir, multiplied by the initial velocity of the first object. Alright? Plus, now we're going to the second object. Mass of the second object multiplied by the initial velocity of the second object, and all that is equal to the mass of the first object multiplied by the velocity of the second object, of the first object. We're working with the first object here. Sorry. There we go. Plus mass of the second object, final velocity of the second object. This one, guys, is the law or principle of conservation of linear momentum. We are going to use it a lot. Now, you don't have to start from there. You can start from either one. You can start from any point and it will be fine. Any of those points will be fine for you to begin the question. Valid point. This is final velocity of object 1. Okay, final velocity of object 1. Yeah, point taken, it's fine. You're right.